Molarity is one of the most common terms of concentration and one of the terms that we will be using a lot this year for the module. Molarity is the number of moles of a substance per liter of solution. And in order to calculate the molarity, you need to know how many moles are there per liter solution. So you basically, if you have any volume of any solution, you need to find how many moles are there in the solution in that volume. And then molarity will equals the number of moles divided by the volume in liter. So how can we calculate the number of moles? So number of moles equal mass over molecular mass. In order to calculate the molecular mass, we need to look up the atomic mass of all the elements in this compound or in this molecule or in this substance. So in order to do this, just look at the periodic table and look up the different atomic mass of all the elements within the compound, and adding that up will end up calculating the molecular weight. So if you have the mass contained in a certain volume, divide that mass by the molecular mass to get the number of moles, and then divide the number of moles by the volume in liter in order to get the molarity. So let's have an example to see how to do this. So typical seawater contains 2.7 gram of a salt, which is sodium chloride, per 100 milliliter. What is the molarity of sodium chloride in the ocean? So the first thing we need to do is to get the periodic table and look up the atomic mass of both sodium and chloride. So if you look up the periodic table, you find that the atomic mass of sodium is 22.99 gram per mole, and chloride is 35.45 gram per mole. When you add that up to get the molecular mass of sodium chloride, it will add up to 58.44 gram per mole. So this is the molecular mass of sodium chloride. So now I need to know how many moles are there. So the moles here will equal the mass, which is 2.7 gram, divided by the molecular mass, which is 58.44. So the answer here will be 0.046 moles. So these are the number of moles of sodium chloride. So in order to get the molarity, I need to divide the number of moles, 0.046, divided by the volume in liter, which is 0.1, because it's 100 ml, so it's 0.1 liter. So your answer will be 0.46 molar. So this is the molar concentration of sodium chloride. Okay, so the second part of the question says magnesium chloride has a concentration of 0.054 molar in the ocean. How many grams of magnesium chloride are present in 25 ml of seawater? To think about that, now we need to get the number of grams. In order to get the number of grams, we need to find how many moles first are there in magnesium chloride, in the 25 ml. In order to find the number of moles, also we need to find in order to find the number of grams, not only find the number of moles, but also we need to find the molecular mass of magnesium chloride. So magnesium, atomic mass of magnesium is 24.30 gram per mole, and chloride, we said it's 35.45 gram per mole. But there are two chloride atoms here for magnesium chloride. So the molecular mass of magnesium chloride will equal 24.30 plus 2 times 35.45. That will add up to 95.20 gram per mole. So this is the molecular mass of magnesium chloride. We know that the number of moles will equal mass over molecular mass. So the mass, this is the thing we need to find, will equal the molecular mass times the number of moles. And we know that molarity equal moles over volume, so moles will equal the moles will equal the molarity times volume in liter. Okay, so if we replace the moles here with molarity times the volume in liter, we will end up that the mass we are looking for will equal the molecular weight or molecular mass times molarity times volume in liter. So molecular mass of magnesium chloride is 95.20. Molarity is 0.054 molar, and the volume here is 25 mil, so in liters this is 0.025 liters. So when you do this, you'll find that the amount of magnesium chloride is 0.13 gram of magnesium chloride. So this is how to calculate, to do the calculation, whether we want you have the grams, the mass in a certain volume, and you need to calculate the molarity, or you have the molarity and you need to calculate the amount of the